Hello everyone, I am Shreya from Sri Venkateshwara College of Engineering, studying in fourth sem Department of Electronics and Communication. Now I am going to discuss about a topic in microcontrollers having the subject code BEC 405A. Now I am going to discuss about basics of interrupts. So firstly, what is interrupt? Interrupts are signal that tells the microcontroller to stop what it is doing and execute a specific function called an interrupt. Interrupts are the events that temporarily suspend the main program, pass the control to the external source, and execute the task. Interrupts are the signal that temporarily halt the main program to perform specific tasks. They help in handling unexpected events or time-sensitive tasks efficiently. 8051 microcontrollers supports both hardware and software interrupts. 8051 interrupts. 8051 microcontroller support both external and internal interrupts. Interrupts are used to handle time-sensitive tasks or events in real-time applications. Interrupts helps in improving the overall efficient and responsiveness of the system. Each interrupt source has a specific interrupt vector address in the interrupt vector table. The priority of interrupt can be configured based on the interrupt enable bits. Now let us discuss about the types of interrupts. 8051 microcontroller has 5 interrupt sources. External 0, internal 1, timer 0, timer 1, and serial communication. External interrupts are triggered by external hardware signal. Timer interrupts are generated by the interval timers when they overflow. So this is the structure of 8051 interrupt priority. Interrupts in 8051 are prioritized based on their sources with external 0 having the highest priority and serial communication having the lowest. When multiple interrupts occur simultaneously, the interrupt with highest priority is serviced first. Priority levels can be adjusted by enabling or disabling interrupt source. Interrupt vector table. 8051 uses a table called the interrupt vector table to store the starting address of interrupt service routines. Each interrupt has a specific vector address where the microcontroller jumps to when the interrupt occurs. By modifying the interrupt vector table, you can customize the behavior of the interrupt. So here we can see the interrupt vector table of the 8051 microcontroller. And next, enabling and disabling of interrupts. Interrupts can be enabled or disabled using the IE, that is interrupt enable register in 8051. Setting the corresponding bit in the IE register enable the specific interrupt source. Clearing the bit disable the interrupt source. And here we can see the example of interrupt enable register. First, all interrupts are disabled after reset, and then we can enable and disable them by interrupt enable register. Interrupt service routine is ISR. When an interrupt occurs, the microcontroller jumps to the interrupt service routine, that is ISR, associated with the interrupt. The ISR performs the necessary task related to the interrupt and then returns to the main program. ISRs should be kept short and efficient to minimize the impact on the main program. Writing an ISR in 8051. To write an ISR in 8051, you need to define a function with a specific name and prototype. The ISR function should include the necessary code to handle the interrupt and clear the interrupt flag. After completing the ISR, the program should return to the main program using the RETI instruction. And Here we can see the diagram of 8051 microcontroller architecture. It containing interrupt control, that is IC, CPU, oscillator, bus control, input-output ports, 4 KB ROM, 128-byte RAM, timer 1 and timer 2. In input and output ports, not P1, P2, P3 are present as ports. Interrupt priority configuration. You can configure the interrupt priorities in 8051 by setting the IP, that is interrupt priority register. The IP register allows you to adjust the priority levels of interrupts by changing the order of their bits. Careful configuration of interrupt priorities is crucial for efficient interrupt handling. Nested interrupts. 8051 supports nested interrupts, allowing an interrupt service routine to be interrupted by a higher priority interrupt. Nested interrupt can be useful for handling multiple time sensitive tasks simultaneously. Proper management of nested interrupts is essential to avoid conflicts and ensure smooth operation. And finally, conclusion. Understanding the basics of interrupts and 8051 interrupts handling is crucial for efficient microcontroller programming. By utilizing interrupts efficiently, you can improve the responsiveness and performance of your embedded system. Continuous learning and practice are key to mastering interrupts handling in 8051 and other microcontrollers. The diagram shows structure of 8051 interrupt. 8051 interrupts play a crucial role in real-time applications by handling time-sensitive tasks efficiently. Understanding interrupts handling, prioritization, and ISR execution is essential for effective programming. Proper utilization of interrupts enhances the overall performance and responsiveness of the 8051 microcontroller. Thank you.